today we're primarily going to be working in a playground again, but I do want to sort of kind of implement some of the Git stuff that we did last time, just to kind of walk you through the full process of creating a Git repository and then getting it up onto GitHub. So let's go ahead and let's open up our Finder window, and I want you to navigate to your development folder, where you guys were, the development folder that we created last time. So let's hop into development and let's just create a new folder here, and let's call it Swift Fundamentals 2. Okay, so again, to create a new folder in this window, if you just right click, you can click on new folder here. So we're going to create a new folder called Swift Fundamentals 2. Okay, and then let's go ahead and let's launch Xcode. And then we're going to get started with a new playground. So I'm going to go to File, New, Playground. Bring it over here for you guys. Okay, and then today you can get started with a blank Mac OS or iOS playground. It doesn't really matter. If yours is already defaulted to iOS, then that's totally fine. Just as long as it's not like a tvOS playground. Yeah, so Mac OS or iOS. Go ahead and hit next here. And then let's save this playground in the new folder that we just created. Okay, so that was in my home directory inside of development, and then my Swift Fundamentals 2 folder. Okay, so let's go ahead and hit create. Okay, and then you should see this empty playground. So we've created a new project, or I guess a new playground. We've put it into a folder, but we haven't set up any sort of Git tracking yet. So we're not able to actually like make commits or push or pull or anything yet. So let's go ahead and initialize a new repository using terminal. Okay, so let's go ahead and launch terminal up. Okay, and then we want to navigate to our Swift Fundamentals folder. Okay, so you can do all of that manually by doing a bunch of like ls, cd, development, et cetera, right? To deep dive into your, to find your folder. Or what you can do instead is if you actually have this Finder window open here, inside of terminal, you can do cd and then just grab the folder that you want to navigate to. Okay, so in our case, Swift Fundamentals 2. Okay, and you'll see that that will actually generate the file path for you so that you don't have to navigate each step of the way. Okay, so I'm going to press enter here. So now I'm in my Swift Fundamentals 2 folder. I want this to be the base of my Git repository, right? So anything that happens inside of this folder, I want to make sure that I track it so that I can commit it and I can go back steps if I need to. Okay. So let's go ahead and initialize a new repository. Okay, and the way that we do that is through git init, right? So git initialize, right? Git init to initialize a new repository. Okay, so then we get this message here that it's initialized an empty Git repository inside of that folder. Okay, so if I do a git status at this point, we can see that there's one file inside of this folder that has yet to be committed and that we're actually not even set up to track yet. Okay, and so you may be wondering, you know, maybe you've forgotten, like, oh, what do we do next? What now? Well, we can see that that terminal here actually tells us what we need to do, right? So it says we have untracked files, and so we should use a git add and then the file name to include that file and what needs to be committed. Okay, so remember kind of the shortcut for adding everything to staging in order to be ready to commit it is if we do git add period. Okay, so git add period just means go ahead and stage everything that's been changed. So we'll do git add period, and then let's do git commit -m, and we'll say set up Swift Fundamentals Playground. Okay, So now our repository has been created here locally, but right now it's not connected. So if I tried to do like a get push or anything, nothing would work, right? Because we don't have a remote repository set up yet, okay? But I want to make sure that everybody's good up to this point. So let's go ahead and have you raise your little Zoom hand when you're caught up to this point. And then for those of you that aren't, ask me your questions and let's get you caught up.
Hey, I have a question. So just, I have two files for some reason there. One of them is a .ds store.
Inside of your...
That's the new repository.
Inside of the new folder?
Yeah, the Swift fundamental. Is this something that it should be, it seems like it's a system file. Because it has the
if you open up the Finder window, do you see that DS store file?
No.
In there? So it's only when you did like a get add or a get status that you saw it?
A get status, right?
I am not 100% sure on that because it shouldn't have added a DS store file.
Right, and when I'm like do that on high, the shift command down, it doesn't show that file. Okay.
Okay, is it at least showing you that you also have a playground file?
Yeah, yeah.
Okay. Go ahead and just stage both of them for now. It's fine.
All right.
It shouldn't impact like your ability to do the project today. So.
Okay. Thank you.
All a DS store file is just a metadata folder for whatever's inside that folder specifically. When you guys learn how to do like docket ignore, there's a file like inside that will make sure it doesn't get pushed up to the GitHub.
What did the docket ignore?
It's nothing you have to concern yourself.
Yeah, for now you don't need to worry about it.
Okay.
Yeah. Okay, cool. So let's go ahead and let's get this connected to a remote repository, okay? So if you open up Safari or whatever web browser you prefer to use, let's go ahead and go to GitHub. Okay. And then we're gonna go ahead and we're gonna click on this plus button here in the top right corner and go to new repository. Okay, and then let's give our repository a name. So I'm gonna call mine Swift Fundamentals 2 for iOSPT6. PT6 here. Okay, and then remember to uncheck initialize this repository with a README, okay? And then let's go ahead and create repository. Okay, and now the next steps are all written out for us, right? Because we want to push an existing repository from the command line. So let's go ahead and copy these two lines. Open up terminal here, hit paste. So Command V, paste, and then press enter. Okay, and if you did everything correctly, you should be able to go back to this web page, hit refresh, and you should see that your playground has now been set up and pushed up to the remote repository. Okay, so when you have that, let's go ahead and have you raise your hand. Okay, all right, so that is the entire, well, not the entire Git process, but that's the Git process up to creating and pushing to our repository. Do we have any questions about any of those steps?
Yeah, I do actually.
Okay, yeah.
So I still need to make the repository, so I'm a little behind from where you're at right now.
Okay, you need to make the repository locally or remotely?
Remotely.
Okay.
So if you could just go back a couple steps, please, sorry.
Yeah, no, it's no problem. So yeah, so to create a remote repository, you're going to navigate to GitHub. And then if you're all signed in and everything, you should see this plus button in the top right corner. Okay. Do you see that? Cool. Okay, so you're going to click on that, and then you're going to click on New Repository. Okay, and then in here, all that you need to do is add a repository name. So we'll go ahead and we'll put in Swift Fundamentals. Okay, and I'll do the test here. Fundamentals. Okay, and then you're just going to make sure that you have initialized this repository with a README. You want that to be unchecked. Okay, and then hit Create Repository. Okay, and then in the command line, you're just going to copy these two lines. So push an existing repository from the command line. So copy both of these, and then just paste them in terminal and press enter, and then you'll be good. I'm going to delete that. Okay, you good, Aaron? Great. Okay, perfect. So let's go ahead and let's go back to our playground here. Let me make the text a little bit bigger so it's easier to read. And okay, so tonight we are going to talk about structs, classes, enums, and optionals, I believe, are the main things that we're going to focus on today. Okay, so when we talk about enums, structs, and classes, we are talking about creating our own custom types. Okay, so up to this point, with all of the Swift fundamentals that we've done, we've been using Apple's built-in types. So we've been using like type array, type string, type bool, type double, type integer, right? These are all data types that are already built into the system, okay? But usually when we're working on apps, we're going to have objects and want to have types that are a little bit more customized to what our application is supposed to do. So if you have like a health tracking app, you may have like an exercise type, right? And an exercise type may have properties associated with it, like duration and calories burned, et cetera, right? So we've done kind of the basic types, but now we're going to learn about how to create our own custom types that can be used in our individual applications, okay? So first off, before we talk about structs and classes, I want to talk about what are called enums, okay? And an enum is short for an enumeration, right? So some people call them enums, I call them enum, whatever you want, right? But it's short for enumeration, okay? And so an enumeration is very similar to a struct data type. But what it does is it allows us to give like a predefined list of cases that a type may have, okay? So we'll do a couple of examples here. Maybe we want to do like an enum for Apple products, okay? You can say that this is an enumeration and all of the cases are of type string, okay? So now I can list off the cases for all of the different types of Apple products, okay? So I could do case iPhone, okay? We could do case iPad, case MacBook, case watch, or something like that, right? So I'm just giving a predefined list of all of the options that are available as part of the Apple products class, or the Apple products enum, okay? So another example would say, let's go a little bit deeper, and let's say that we want to do an enum for a pizza category, right? So I'm creating an app that will allow users to order pizza, and there are 3 different categories that a pizza can be, okay? So I'll say enum pizza category, and all of my cases are going to be of type string. Let's go ahead and do case classic, case specialty. Okay, so we'll have a specialty category, and then we'll do gluten-free, case gluten-free. Okay, so now these are all the predefined possible pizza categories that I can have. Okay, so one way that we create an instance of a pizza category is we would do it just the same as creating an instance of any other type, right? So let's go ahead and say, let specialty pizza equal pizza category, and then we access this different cases through dot syntax. Okay, so I'm going to do dot, and then you see that we have our classic, gluten-free, and specialty. Okay, so again, this is going to be a specialty pizza, so let's go ahead and set the category as specialty. Okay, so if you want to reference this through dot syntax, you will need to include the enum type here, pizza category. And that's because type inference has no idea. If I go here and I say dot specialty, it doesn't, the type inference doesn't know that we're trying to reference our pizza category enum, right? So I do need to put pizza category before this in order to be able to access that specialty case there. Okay, but one other way that I can do this is I could say, let my favorite pizza of type pizza category. Okay, so now there's no more type inference. Now the compiler knows that my favorite pizza is going to hold a pizza category. So now when I put equals, I can just access my case through dot syntax, right? I don't even need to include pizza category dot, because it already knows that it's going to be of type pizza category. Okay, so I could go ahead and do dot classic. Okay. Questions about enums?
Hey, John, for us, when we access the pizza category at that point, can we consider the classic more as a data type then at that point? We're making like a custom data type?
So it's sort of. It's hard to know exactly what you're thinking, but yeah, like when my favorite pizza is of type pizza category classic. So its type is a pizza category, but it's more specifically a classic pizza.
Okay.
Okay. So these different cases, they don't have any like sub properties, right? Like there's nothing about a classic that necessarily distinguishes it from a specialty besides the fact that one is classic and one is specialty, right? So in that sense, it's not really like of type classic because there are no other attributes associated with those enums, right? There are no like sub properties to these different cases. Does that make sense?
Yeah, it does. I was thinking more like a string when I was thinking data type in my head. So no, this makes sense.
Oh, I see. Yeah. So what we could do is if I wanted to like print off my favorite pizza, okay, and we run this. Okay, we see that it is a string, right? So the raw value of the case is a string. So yeah, sorry, I guess I misunderstood your question.
No, it's all good. Thank
so
you.
Right here, yeah, so we're almost just kind of aliasing these categories, but it's nice because instead of having to, say pizza category equals, we're starting to introduce some potential user error here. Is if I have to go in and type in my case every single time that like this is classic and this is going to be, specialty, and like I misspell specialty, right? That's potential for user error. So by having an enumeration, we're like guaranteeing that we're always going to have the same 3 categories, right? Because they're going to be of type pizza category that only has 3 possible cases.
So by doing this would help us eliminate that user error?
Mm-hmm. Correct.
Okay.
Yep. So now any pizza well, and we'll get more into this, but now anytime I'm using pizza category, I'm guaranteed that it's only going to be one of these three things, okay? Even though they are of type string, if I try to type something that is not in my pizza category enum, the compiler is going to warn me and say, hey, that's not part of your pizza category type, right? So it's a predefined list of all of the potential options that you can have. So it kind of helps us like hone in on and categorize like things that are possible to have as part of this type. Okay, but this is just like one little piece of the puzzle of, you know, right now this probably doesn't look super useful, but now let's go ahead and let's create a class that has a property on it of type pizza category, okay? So let's go ahead and, sorry, before we do classes, let's do structs, okay? And let's say we have a struct for a pizza, okay? And my pizza type has three properties. We have the name of our pizza, which is going to be of type string. We have the cost of our pizza, which is going to be of type double, right? Because we want to be able to say like, oh, $12.99, $13.99. Okay, and then every pizza is going to have a category, okay? And that's going to be of type pizza category. Okay, so we'll go ahead and we will create an instance of a pizza. So let's go ahead and say, let my pizza equal pizza. Okay, and now we see when we want to initialize a pizza, I have to pass in a name, a cost, and then a category, okay? So let's go ahead and give this a name. We'll say 49er, okay? And we'll give it a cost of $12.99. Okay, and then here's where that idea comes in of like not introducing more potential like user error, is that for my category, I can't just simply type in, you know, vegan or something, right? Because vegan is not, even though vegan is a string, it is not of type pizza category, right? So I can set the category simply by doing dot syntax and saying, okay, the 49er is a classic pizza. It's just like a regular pepperoni pizza. Okay, so the category is dot classic.
Would you have the ability, say, to insert a new case in that category, if need be? Like you know how in directories we're able to insert new values. Is that possible to do?
Yeah. So generally enums are going to be predefined. So you'll need to define all of your cases in here, inside of the body of the enum.
Gotcha. So there's no like special thing that you would have to do. Just go in there and put a new case.
Yeah, correct. Yeah, you would just need to predefine it here. Okay. So now we've got a pizza. We can go ahead and let's print out. I would like to order a, and then we'll interpolate our my pizza dot name. Okay, and then we run this. I would like to order a 49er. Okay, any questions about structs?
I do have a question. However, it's not about structs. It's about the enumeration. So I just thought about it. Sorry.
Okay, no, you're good. What's up?
For the enumeration, when you're declaring its type, for example, like type string, would you be able to not declare the type and then just declare the type for each case, like case classic, type string, case, I don't know, something that would have to be an integer?
So you could, you generally don't do that, because really what it would have to be is it would have to be an enum of type any.
Oh, okay.
And generally you want to make sure that like all of your possible categories should be of the same type, right? So
Okay.
I can't think of a use case of when they would be different types.
Okay.
But one thing that I will touch on in that case though is, so say, for example, we have watch here, okay? Well, watch is just a singular, and I could even do, let's do like lowercase watch and lowercase MacBook, okay? Well, because these are gonna be of type string, like the raw value of these cases is literally watch, like lowercase. Okay, well, wait, maybe whenever we have an Apple product that is of that type, we want to have like the more official name. So you can define like the more official name of that case, okay? So that the raw value of my case watch is actually the string Apple Watch. Okay, so I can set that in here so that if, for example, I wanted to, print Apple products.watch, it would print as, come on. Yeah, as the raw value, it would print out Apple Watch. Okay, so before I do that, if I were just to print that out, it would just be watch, right? But if I explicitly state what the string should be, then the raw value for that case is going to be Apple Watch. Okay. Okay, other questions up to this point? Okay, so yeah, so structs are a really effective way to just simply create your own object, right? Because all you need to do is give it its property names as well as their types, and then you're good to go, okay? What structs come with is they come with a member-wise initializer. And what a member-wise initializer is it's just an initializer that allows you to create an instance of that object, right? So when I say let second pizza equal pizza, okay, this right here, this is the member-wise initializer that's given to us by the struct, or it gives us a way to create an instance of that object, okay? So classes, on the other hand, require you to create your own initializer, okay? So let's go ahead and create a class for a pizza place, okay? So see how we're kind of like growing bigger as far as like what our categories entail, right? So we've got our pizza category, and a pizza category is part of a pizza. And so now we're going to create a pizza place that has a variety of pizzas, okay? So let's say class pizza place here. And we'll say that our pizza place has a name, has an address, type string, and then it has pizzas, right? Different kind of pizzas that you can order, okay? And that's going to be an array of type pizza, okay? So if you're caught up to this point, you should see an error, and it says class pizza place has no initializers, okay? And what that's saying is it's saying, hey, you haven't given me any way to like initialize, like when creating an instance of pizza place, there's no way to initialize a name, address, and pizzas, okay? So what we need to do is we need to create our own initializer, okay? So create initializer, okay? And the way that we create an initializer is it's going to look pretty similar to a function, except that it starts with the word init instead of func, okay? So we're gonna say init, and then inside of the parentheses, all of our parameters are going to be parameters for our properties, okay? So we want to be able to initialize a pizza place with a name of type string and an address of type string, okay? And then inside of that initializer, we're gonna set self.name equal name and self.address equal address. Okay, but then we still see an error that says return from initializer without initializing all stored properties. Okay, well, I only care to have a user only needs to, well, I guess I should say user, I should say developer, as I want to make it so that I'm not required to pass in an array of pizzas when I create an instance of a pizza place. So I'm gonna go ahead and give self.pizzas a default value of an empty array, okay?
Johnny, why didn't you initialize pizzas again?
Yeah, so let me show you. We'll kind of play with this example a little bit more. Okay, so let's say that I'm going to say let Johnny's pizza place equal, and this is going to be a type pizza place. So as soon as I do my open brace, I'm going to see my initializer. Okay, and the initializer again is the arguments required in order to create an instance of this type. Okay. So we can see that in order to create an instance of a pizza place, I'm required to pass in a name and an address, okay? And that's because I specified in my initializer here that in order to create a pizza place, I only require a name and an address, and then pizzas will just have a default value of an empty array, okay? So I'm just making it easier for myself as a developer that's like, I want to be able to create a pizza place without necessarily having to pass in all of the pizzas at that given moment, right? I can adjust that later. Like if I have a pizza place here and I say Johnny's Pizza, and that's at 123 Delicious Avenue or something, right? Well, I can specify it later and I could say Johnny Pizza Place dot pizzas is equal to, and then I can create an array of pizza objects later, right? I'm just not required to initialize the pizza place with a pizzas array, okay? So again, I can modify that and I can say, okay, well, let's say that I do need to include pizzas, okay? Well, I'm gonna put that inside of this initializer, and then all of a sudden, the compiler is gonna get mad at me and say, hey, you're missing an argument. You have to initialize this with pizzas, right? So then it's requiring me to pass in a list of pizzas. Well, that's sort of a pain, right? Because then I have to go create pizza objects and whatnot. And so I'd rather just do that later. So that's the reason that I'm giving pizzas, I'm not including it as part of my initializer, and I'm giving it a default value of an empty array. Okay, does that make more sense, Sammy?
Yeah, it does, especially because if you don't have all the information, you're just trying to get through it. I can definitely see it.
Yeah. Let's go back here. Okay. Any questions about creating an instance of a class? Does everybody understand what I mean when I say creating an instance? I know that that's one of those kind of like vocabulary lingo that I may be throwing around and you're all like, what is he talking about? What's an instance? Does that make sense to everyone, or what questions do you have about that?
Could you just do a quick recap about instance in a class?
Yeah. Okay, so pizza place up here right now, this is our class declaration, okay? And what this is simply a blueprint of a pizza place object, okay? And so if you think about, like if you're an architect or whatnot, right? Architects, they build houses, but before they build houses, they generally have like a blueprint or like a floor plan that tells them what they need to do and what they need to have in order to build a house, right? So a class declaration like this is simply a blueprint of what an actual pizza place object needs to have, okay? So we have our class declaration, which is our blueprint. And then when we initialize an instance, or when we create an instance, that's like an architect like actually building the house, right? We have a physical house, and then we also have the blueprint for the house. Okay, so similarly here, this is a blueprint for what a pizza place has to have. And then Johnny's Pizza Place is actually like not a physical thing, but it's an actual pizza place object that I can interact with that has properties and values associated with it. Okay, does that make more sense, Sophia?
Yes.
Okay. Okay, any other questions?
So I'm still a little fuzzy or a little confused about the why for class we have to do the initializer function, and then on struct we don't. Yet when we create the instances, we still gotta put in the information for both. Like we're doing the same thing at the end for the instance, but I don't know. I'm still
Yeah, that's a good question. We'll get more into the differences between classes and structs. So yeah, like into more of the details behind that. So yeah, so one thing you will have to remember is that classes, they're always going to make you to create your own custom initializer. Okay, and structs you still can. You can create an initializer for a struct if you want to specify, you know, I only want to initialize it with a name and a category, right? So I could say init name category of type pizza category. Okay, and then we could set self.name equals name and self.category equals category. And then we'll just say self.costs is equal to 0 for now. Okay. So let me show you how that changes things. Okay, because I gave it my own initializer. Pizza. Okay. So now we can see that to create a pizza, now I only have to give it a name and a category, right? So I created my own custom initializer for this pizza object. Okay, and what I could do is if I wanted to make it even more dynamic and say, okay, well, maybe in some cases I do want to pass the cost in, but I'll give it a default value of 0 in the argument, okay? And then I'll say self.cost equals cost here. Well, now what that does is if I say pizza, now you can see I have 2 ways to initialize a pizza object. I can initialize it with the cost or without the cost, okay? So I can add custom initializers as needed to make things easier for me as an engineer, but also there may be times where I want to create an instance of a class without actually being required to pass everything in. So I can give default values to the arguments so that I can set them later if I need to, or if I want to make sure that I'm like preventing accessing a class outside of a certain time, I can do so, okay? But yeah, so structs will come with, and again, let me do this real quick. So pizza, right? Structs will come with their own member-wise initializer. And the reason it's called member-wise initializer is because it initializes every member of that, like the initializer itself initializes every member of that struct or of that type, right? So it will always include the arguments for each of your properties that you have. Okay, does that help a little bit, Aaron?
Yes, it does.
Okay.
I have a question. Is there a limit to the amount of custom initializers that you can give each custom data type?
No, yeah. I mean, usually you only have like maybe between like 1 and 3. I don't know if I've used one that has many more than that, but I don't think that there's a limit because you can choose how you want to initialize it in any way. Because like maybe if what you want, like maybe you want to create an initializer that you're like pulling from an API and you just want to be able to initialize a pizza object from like a JSON data object, right? Then you would create a custom initializer that just takes in that JSON data object directly and converts it into a pizza object. So yeah, you can set up as many initializers as you need. Okay, other questions?
So predominantly, I mean, obviously there's quite similarities between structs and classes. The reasoning why you would choose one over the other would be likely a case where you want to have like a value type as opposed to a reference type. Would that pretty much be why you're setting one as opposed to the other?
Yes. Yeah. So yeah, we'll talk about the difference between value types and reference types after we take a quick break. The other like big key behind using classes is that classes allow you to subclass. So you get like that, you get inheritance out of it. Whereas with structs, you cannot subclass struct because it's a struct, not a class, right? And so that's when you want to use classes, is when you know that you're going to want to like be able to subclass it and whatnot, then you want to use a class. But yeah, anyway, we've been going a long time without a break, so you guys deserve a little bit of a break. I'm going to go ahead and give you 4 minutes. All right, everyone, let's come on back. Bring it on back. Don't forget to turn on your cameras so that I know you guys are actually back and listening. All right, okay, so going along with our pizza place here, so remember I gave pizzas an initial value of an empty array, okay? And one reason that you may want to do that is you would want to make sure that in order to add pizzas to your pizza place, that can only be done through like a method, okay? So let's go ahead and I'm going to, so as I showed you down here, right now, if I wanted to set the pizzas, I could do Johnny Pizza Place dot pizzas equals, and then I could pass in an array of pizza objects, okay? Well, maybe I don't want that to be like easily accessible. Rather, I want that to only be allowed to be set by the class itself, okay? So what I can do is I can put a private, so I'm gonna say private set var pizzas, okay? Meaning that I can only access pizzas inside of my blueprint, inside of my class declaration, okay? But I can have an external method, okay? Does anyone know what a method is? What is a method?
Function inside of class.
Function.
Yeah, it's the same as a function, just as part of a class. So instead of like a freestanding function, it's just a method. It's a function that's part of a class. So I'm going to have a function that can be used to add a pizza. So we'll say func add pizza of type pizza. Okay, and then this we'll call pizzas dot append, and then let's append a pizza. Okay, so now I've restricted the only modification that I can make to my pizzas array is via this method add. Okay, so I cannot access pizzas directly outside of the blueprint itself. I can only access it through this add pizza method. Okay, so if I try to run this, or sorry, let's go ahead and let's say if I try to add some pizzas, so I'll say Johnny Pizza Place dot pizzas is equal to an array of dot pizzas is equal to an array of pizza test cost, we'll say 0, and we'll say gluten-free. Okay, so I'm going to get an error here, and it says cannot assign to property pizzas because the setter is inaccessible, saying that I can't set the value of pizzas directly, okay? And that's because I used this private set here that says that the setter can only be accessed inside of the class itself, okay? So right here inside of add. Okay, so in order to add pizzas, I need to use that add method. So let's go ahead and let's create a few pizzas. So let's say let Hawaiian classic equal pizza, and let's call it the Hawaiian classic. We'll say that it costs $12.99, and the category is going to be type classic. Okay, let's add a couple more. Let's say we've got a chicken Alfredo pizza. So we'll initialize a new pizza object. Okay, and let's call this, call me Mr. Alfredo. Okay, and because it's a specialty pizza, we'll say that it costs a little bit more, and its category is specialty. Okay, so let's add one more. Let's say we've got our margarita pizza. Okay, and let's initialize it with the name. We'll call it our margarita señorita. give it a cost of $16.99. And our category is going to be our gluten-free pizza. Okay, so again, if I want these to all be pizzas at Johnny's Pizza Place, how am I going to add those to my pizza place? What do I need to do?
Make a menu.
Use the add function.
Use the add function, right? What did you say, Sophia? I missed it.
I'm sure that the add function is correct, but I would like make a menu. So, and then string all of those options together.
Okay, so have them all be part of like an array, you're saying? Like as an ordered list of items? Okay, yeah, so that's one way that we could do it. And if I didn't have this set to be a private set, I could do that, okay? But what I've done is I've restricted pizzas to only be accessible via this add function, right? So normally if I didn't have this private set here, you're exactly right. I could create an array, put all of the pizzas in it, and then just assign Johnny's Pizza Place.pizzas equals my array of pizzas, okay? But because I've got this private set here, I can only access it through this add function. So let's go ahead and let's add each one of these pizzas. So we're going to say Johnny's Pizza Place dot add, okay, and then let's pass in our Hawaiian classic. Okay, we'll do Johnny Pizza Place dot add our chicken Alfredo, and Johnny Pizza Place dot add margarita. Okay, so now that all of those have been added, if I want to print out Johnny's Pizza Place dot pizzas. Okay, remember it's only the setter that is private, not the getter. Okay, so I can read what the property is, I just can't set it outside of the class, right? So if I print this out, it kind of reads like a bunch of gibberish, right? We get this LLDB expression, but we see that I've got one pizza here, I've got the Hawaiian classic, I've got the Call Me Alfredo, and then the Margarita Senorita.
What does LLDB expression mean?
So what it is it's because these are because I'm saying print, generally when you print something, it's like a string or it's an integer, but I'm saying print this object, okay? Like it's a complete object. And so this is just sort of like Xcode gibberish. That's just saying like, this is an object that's being printed out, not necessarily like a string or anything.
So we generally don't have to pay attention to that then?
Right. Yeah, we're more focused on this part here where it says our actual pizza. Okay, because you can see it says the same thing here, that we're printing out a pizza category, which again is an object, not like a general string. Okay.
Is there a way to clean that up so it doesn't look like that with all the extra stuff, I guess?
So you could like set up like a method that prints out, like we could do like a function here to print pizzas. Okay, and it takes in an array of pizza objects. Pizzas takes in an array of pizza. Okay, and then we could say for pizza in pizzas, print, and then we could create like a string here and interpolate the pizza name, et cetera, right? But again, that's just, you can do that if you need to, but yeah, generally, just for our cases today, because normally you're not really gonna care to print anything out, like in the real world app, you're not printing anything. You are gonna just have these objects. And so this is more so just checking, like doing a sanity check, making sure that our pizzas array actually has the pizzas that I just added to it.
Do you have to add all of the pizzas individually like that, or is there a way you can kind of I mean, it basically, does it have to be add Hawaiian Classic, add Chicken Alfredo, etc., or can you do like comma and add pretty much a whole bunch at the same time?
With the way that our class is set up, that's the only way to add a pizza, right? Because pizza's array is only accessible via this add pizza.
Right.
But you could create another function in here that says add pizzas, right? And this takes in an array of pizza objects. And then we could say, you know, self.pizzas.append contents of our pizzas array. So that's one way. It's just create a method that takes in an array of pizza objects and then pass in an array.
Gotcha. Okay, thank you.
Yeah.
Johnny,
Okay.
what's the main reason that we would set the pizza variable to private?
Yeah, so generally you'll use this when you're creating what are called like model controllers. So it's important that that in order to like make your code safe and in order to keep like your data clean, you want to like focus on limiting or restricting access to certain properties from other classes or objects, right? And so that I can verify that, you know, maybe a model controller that I'm setting up, I can verify that its data source is clean and proper because I've said that this can only be set within the class itself. So if I'm like in a different class and I try to set like Johnny's Pizza Place.pizzas directly, that could like mess up the data source that I thought that I had, right? And so I'm limiting or restricting the access that other classes have to the setter of my pizzas so that I can sort of verify that everything is being added to the array of my pizzas array, like in a certain way. So I'm sort of giving myself more control of how this this object can be interacted with, if that makes sense.
Yeah, it does. Thank you.
Okay. Okay, so let's talk about the difference, and Ian touched on this a little bit. We're going to talk about the difference between value types and reference types, okay? So a struct is equal to a value type, okay? And I'll show you what that means. So let's say that I've got a struct for a ticket, okay? And the ticket has a name on it, okay, of type string. So that's my blueprint for any kind of ticket object that I want to create. Okay, so now we'll go ahead and we'll create an instance. I'll say var ticket equals ticket, and let's initialize it with a name. We'll say Bob. Okay, so if I were to print out ticket.name, what would we see?
Bob.
Right, ticket.name, the name is equal to Bob. Print that out, we see that we get Bob. Okay, well, let's say that I want to create a ticket copy. Okay, and my ticket copy is equal to my ticket, okay? Well, let's go ahead and let's call ticket copy dot name is equal Johnny, okay? So I've got a ticket and I've got a ticket copy, which is equal to ticket, and now I set the ticket copy's name equal to Johnny, okay? So because I've set the ticket copy name equal to Johnny and ticket copy is equal to ticket, what is going to be the name on ticket if I were to print out ticket.name again?
Still Bob.
It would still be Bob, okay? So let me show you that here. So let's go ahead and let's print out ticket, okay? And then we'll interpolate our ticket.name. Okay, and then we'll print out ticket copy. And then do ticket copy dot name and run this. Okay, we see that ticket is equal to Bob and ticket copy is equal to Johnny. So even though I set the ticket's copy ticket copy.name equal to Johnny, it had no impact on my initial ticket, okay? And that's because structs are value types. And so, the value is not passed by reference, but passed by value. So it creates a copy of that ticket object, right? So ticket copy and ticket here, even though ticket copy is equal to ticket, it's a copy, right? It's not referencing like the same instance in memory. It's simply a copy of it. So any changes that I make to the copy do not affect the original, okay? And so that's how this idea of value types is that we pass things by value, not by reference, and that they're creating copies of each other. They're not accessing the same point in memory, okay? And I'll show you the difference here in just a sec. So let's create a func here to change our ticket name. Okay, so we'll say func change ticket name, and it takes in a ticket object. Okay, and let's say we've got our updated ticket is equal to the ticket that we pass in. Okay, and then we'll set our updated ticket.name equal to John. And then let's print updated ticket and pass in our updated, updated ticket dot name. Okay, so similarly, if I print out my ticket here, my original ticket, ticket.name, but then I call my function change ticket name and pass in my ticket object. Okay, and then let's print out this same one again. Run it, and updated ticket, oops. Okay, so we run it, we see that the original value of ticket is still unchanged, right? So we've got ticket Bob, and then we've got our updated ticket, which we set to John, okay, but then the value of ticket is still equal to Bob, right? So again, in here, even though I'm passing ticket in as a parameter, it's simply passing it as a value type and creating a copy of it.
Quick question. In the videos that were posted as part of the learning, or the prepare, I should say,
Yeah.
the objects were defined as a let as opposed to a variable, and yet it was still changed. So how, it just kind of confused me a little bit because I thought that a let was immutable, and yet it did still change. Can you explain that?
Yeah, so that's a bit of how can I say this? It goes a little bit deeper with like the reference types and the value types. Because if you have let me get to the reference type aspect, and then we can come back to it. Is that okay?
Sounds good. Yep, okay. Perfect, thanks.
Okay. So value types, remember, they create copies of each other. Whenever they reference each other, they're actually creating a different copy. So if you make a change to one, it does not affect the original, okay? So let's talk about reference types here. Reference types, okay? And this is where we're using class objects, okay? So let's create a different kind of class. Let's do class for a city, okay? And we'll say a city has a name of type string and a population of type int, okay? Again, in order to initialize this, I'm going to need to create an initializer. So let's initialize it with a name of type string, population of type int, and then we're going to say self.name equals name, and self.population equals population. Okay, So let's go ahead and say let Rochester equal city, Rochester, New York, and let's give it a population of 208,000. Okay, again, you don't, this underscore is not required, but it is allowed, you're allowed to use underscores in order to make your numbers more readable. So where you would normally, like if you're writing numbers where you'd normally put commas, you can put underscores. Okay, and then let's say that we have another property here, let ROC equal Rochester. Okay, so let's go ahead and set roc.name equal to ROC. And then let's go ahead and print out Rochester, and we'll interpolate our Rochester.name. And then we'll print out ROC and interpolate ROC.name. Okay, so before I actually run this, what do we expect each of these to print?
ROC.
Okay. Okay, well up here, remember with these, we saw that it printed ticket name was equal to Bob and ticket copy.name was equal to Johnny. But if we go down here and run it, we see that they both print out ROC. And that's because classes are passed by reference, okay? So when I say that ROC is equal to Rochester, they are both accessing the same location, or referencing, I should say referencing, not accessing. They're both referencing the same location in memory, okay? So a change to one is going to denote a change in the other because they are both referencing the exact point, the exact same point in memory, okay? So structs.
Johnny?
Oh, yeah, go ahead.
What's the word for that when like they all point to the same value?
They're all referencing the same like value in memory. And that's why we call it a reference type, right? It's because they're referencing the same value.
Okay.
Yeah, I don't know exactly like the exact word that you're looking for. But like, yeah, that's what I would say is that they are both referencing the same value. Okay. Okay, so that's one of the biggest differences between classes and structs, okay, is that structs are value types, okay, classes are reference types. So structs pass by copy, right? So whenever we reference, when we say, you know, with my example up above, ticket copy is equal to ticket, we're just creating a copy of it, not referencing the same value in memory. Whereas with a class, it's a reference type. So in this case where ROC is equal to Rochester, they're both referencing the same point in memory. Okay, so let's write out a function here to increase our population. Okay, so I say func increase population. We'll pass in a city object. Okay, and we'll say city.population is equal to city.population plus 1. Okay, so now if we print out Rochester population and we interpolate that here, Rochester.population, and then call increase population for Rochester. And then print it out again. Let's see how that changes things. Okay. So we see that previously, for our method that we made up above to change the ticket name, whenever we called this method and we passed in our ticket, the original ticket remained unchanged, right? So our updated ticket got the value of John, right? And that's what we print out, but it didn't change the value of ticket itself, okay? But now things are a little bit different, right? Is we're actually passing in our Rochester object. And so that when we update it, when we increment the population of Rochester, it's going to change that value at that location in memory, so that any other instance that may be like referencing that value in memory is also going to be changed. Okay. So now if I print out roc.population, okay, we see that roc.population is also equal to that, right? Okay. Let me just check on our time. Okay, so Ian, getting back to your question of using let versus var, et cetera, let's go down and just create a couple of other classes here that will be a little bit easier, okay? So if I have a struct here for a, let's just do a person. It's always the easiest one. Okay, and we'll say var name is a type string, and var age is of type double. Okay. So if I say, okay, let me equal person, and we give name Johnny, age 28. Okay. So if let's say that I want to change my age. So I'm going to say me.age is equal to 29, right? I have a birthday, and then we print out me.age. Okay. So here we see that although the properties inside of person are variables, person itself is unchangeable, right? So let me, when I say let me, I'm saying, hey, this person object is unchangeable, okay? And so what I would need to do if I wanted to increment that age is I would need my me property to be a var, and then I'd be able to increment my age, okay? Well, if I do something similar with a class here, say class person, okay, and we've got var name of type string, var age type double, and then we've got our initializer that takes in our name, type string, age. And I'm typing fast because I don't expect you guys to follow along with this. Self.name equals name, and self.age equals age. Okay. Class person 2. Okay, so now if I create an instance of this with a let constant, a person 2, Johnny, age 28. Okay, so now if I say me2 dot age is equal to 29 and print out me2 dot age, okay, we see that it doesn't have a problem incrementing it, okay, even though me2 is a constant, okay. And so the reason for that, and this is another one of the differences with classes and structs, is that classes allow you to modify the properties within them. The let constant means that like you cannot assign another person object to this, right? So I couldn't do something like, okay, well now me2 is equal to a completely different person 2 object with the name, you know, John, age 30. Okay, we'll see an error because in that case, me2 is a let constant. We can't make any changes to it. Okay, but as long as it's a class, I can make changes to the properties within, okay, as long as they're variables. Okay, so Ian, there's a lot of stuff going on here and like behind your question. Am I even answering your question? Am I doing something completely opposite, or?
Yeah, no. That does actually make a bit of sense. Basically, it almost like the when you designate something in class, it gives you a form of limited mutability kind of later down the line, as long as you stay within the confines of the class. So no, that does answer it.
Okay. Okay, cool. All right. Okay, so let's talk a little bit about the idea behind creating custom initializers. Okay, so let's create a new class for a vacuum. Okay. Okay, so a vacuum object here has a few properties. It has an is-on property, which is of type bool. We have a property is plugged in of type bool. Var rug height type int. Okay, and that could be something like, 1 to 10 millimeters. Is it a self-driving vacuum? So it's like a Roomba. Okay, we'll make that a bool as well. And then, vacuums generally come with attachments that you can add to them in order to get to different places. Okay. Okay, so again, with classes, we have to initialize all of the properties somehow, either through the initializer or give each property an initial value. Okay, so I'm going to create my initializer here. And let's go ahead and say is self-driving of type bool is equal to false. Okay, and then attachments of type string, array of strings, is going to be equal to an empty array if I choose not to pass anything in. Okay, so let's say self.isOn is equal to false. We'll give that an initial value of false. Self.isPluggedIn is equal to false as well. Self.rugHeight, let's give it an initial value of 5. And self.isSelfDriving will pass in is self-driving, so whatever we initialize it with, and we'll do the same thing with attachments. It's equal to attachments. Okay, so now in my initializer, I have specified everything has been initialized with either a default value or initialized with what the user or what the developer is eventually going to pass in, right? So is self-driving here is going to be used to set self.isDriving, and attachments is going to be used to set self.attachments. And then these three all have initial values, okay? So if I want to create an instance of a vacuum, so we'll say let shark vacuum equal vacuum. We see that I actually have two initializers, okay? Who can tell me why I have two initializers here? Okay, I can initialize it with nothing if I want, right?
You set a default value, so there's going to be two, one with the default value and one without.
Yeah, exactly. So is self-driving is equal to false and attachments is equal to an empty array. So I can't actually get away with initializing a vacuum without any parameters, okay? But then if I wanted to print out, shark vacuum dot is self-driving, well, that would be equal to false, right? Because that's the initial value. If I wanted to print out shark dot attachments, that would be just an empty array. It wouldn't have any attachments associated with it, okay? And then is on, is plugged in, and rug height, those would all be equal to false, false, and 5, okay? So those are the different ways that we can sort of modify our initializer, is that we can give it default values in the initializer, okay? Which just gives us freedom to choose not to initialize it with certain properties, okay? But everything inside of the class must be initialized one way or the other, either through what the user is passing in through the initializer, or just given default values inside of the initializer itself. Okay, so again, let's do, where did my shark go? There it is, shark. Okay, so I'll initialize a shark vacuum here, vacuum. And we'll say is self-driving is equal to false. And then the attachments, we'll say we've got a dusting brush and a crevice tool. Okay. So again, if I were to print off is self-driving and attachments, they would be what the user actually physically passed in here. But if I were to print out rug height and is plugged in, is on, those will all be set with their default values. Okay. Let's create a Roomba in our case here. So let Roomba vacuum equal vacuum. Okay. And what I can do is I can give is self-driving a value of true. And then because attachments already has a default value, it will be an empty array if I initialize it with nothing. I can actually just get rid of that. Okay, and we'll say that the Roomba vacuum doesn't actually come with attachments. So if we print out Roomba vacuum dot attachments, we see that it's just an empty array here. Okay, what questions do you guys have about initializers?
So I have a question. When we do self is self-driving, and then it equals to self-driving, it actually gives me an error saying assign a property to itself.
Yeah, so you want to say self is driving, and then this should just be the name of your parameter here. So not self is driving.
I see.
It's
okay.
it's the name of what's being passed in here.
Okay.
So yeah, that gets a bit confusing, like when you have the exact same names, because you actually don't even need to include self. You could just say is self-driving equals is self-driving. Okay, and the compiler can generally, let's see. Normally that works, but I guess in this case we do need to say self to denote that we're referring to like this is self-driving, but then this is self-driving is from our parameter.
Got it. Okay.
Okay.
Could you have set the value of the properties up when you first called them? Like in vacuum, when you first put var is on, bool, yeah, put equal, true, false up in that area.
Yeah, you can do that as well. And so then they wouldn't be required in the initializer. So I could say is plugged in equals false. Rug height, we could say 5. And let's leave these two. Okay, so then I don't need to include these.
Is there like advantage or disadvantages doing it either of those way? Does it matter, or it's just preference? Sorry.
Yeah, I want to say, I'm not sure which way is like the most efficient way. I want to say that in practice, this is more common. At least the way that I use it at work. I usually, if I don't need something as part of the initializer, then I usually give it a default value outside of the initializer method.
If you were to do it like how you have it right now, where the bool is false, doesn't that remove your ability to change it though? You're making that basically like this is how it will be unless I go back into the vacuum class and edit it.
Not necessarily, because these are variables. So they allow me, so because they're variables, they are changeable.
Okay.
Yeah. Initializer is just used when creating an instance. Like what do you want to happen or what values do you want to set when creating an instance of this? But But that doesn't take away my ability to modify them here. If all of them had like a private set on them, then I wouldn't be able to access them except through the initializer itself. But because they're just open vars here, I can still modify them after the instance has already been created. Okay, does that make sense? Okay. All right. So we're going to kind of change gears here, unless there are any other questions on classes and structs.
Hey, Johnny.
Yeah.
So you type in vacuum dot is plugged in to change that false to true, wouldn't it?
Uh-huh.
Okay.
Yeah. Yeah, exactly. Okay. So we're going to move, and I'll have some time at the end if there are more questions on classes and structs, but if most of you feel pretty good about those and you want to move on, we'll go ahead and we'll move on. Let's talk about this idea behind optionals. Okay. So who can tell me what an optional property is? When I say that something is optional, what's that mean?
It could be nil.
Okay. So yeah, so up until this point, we've said that we've never created any optional properties before. We've said that every property that we have must have a value. Okay. And so if I have a property, say var my string of type string, okay, I need to give it a value. Okay, say that this is equal to Johnny, or my string, or whatever, right? Okay, but we can make a property optional by saying that by after the type declaration putting a question mark. And what this is saying is that my string can be equal to a string, or it can be equal to nil. Okay, so properties in of them, if a property is not optional, it means that it must contain that type. Okay, it cannot be equal to nil. Okay, but when I say that something is optional, I'm saying that it indeed can be nil. Okay, so let's do a few examples to kind of play to this point. Okay, so let's say that we want to represent like a car. Okay, like a car that you have. Okay, some of us have cars, some of us don't have cars, right? Some of us may not need a car. I work my office is so close, like I personally don't have a car. My family has a car, but I don't have my own car. So let's go ahead and say, okay, if your work is close and you don't own a car, then let's go ahead and say var my car, okay, is of type string optional, and for me it's equal to nil, right? Okay. Well, let's say that, I changed jobs and now I do have a car. Okay. Well, now I can set my car equal to, let's say that I buy like a Subaru. Okay. But then sadly I get into a car accident. I get into an accident and total my car. Okay, so now my car is equal to nil again. Then I got insurance money to get another car. Okay, so now my car is equal to Tesla. I got a lot of insurance money, so I got a cool Tesla.
That's a hell of a payoff.
Okay, and then I have 4 kids and have to get rid of my Tesla. So then we set my car equal to like a Toyota Sienna or something, right? That minivan life. Okay. So this is to illustrate this idea of an optional property. Okay. But this is a variable, so it is changeable. And I can sort of change the property to be a string or another string, or it can be nil, depending on a certain situation, okay? And so the question is, why do we need optionals? Okay, when are optionals ever actually going to be used in practice? Does anyone know?
Well, I mean, in a lot of the cases we had with the pre-coursework was like, say, for example, you're establishing a user's name. Do they have a middle name? Maybe they don't have a middle name. So you have to have kind of a placeholder to allow for that circumstance.
Yeah, exactly. And so one of the cases that you'll see the most as a developer is that a lot of your applications are going to be focused on like user input, right? So usually your app has like a text field that allows them to type in literally anything they want, right? If you're saying, what's your weight? And they type in ABC, well, we need to allow for the user like passing in like an invalid value, right? And so let's say, for example, that you know, we do in our app, we do say that we have like weight, okay, let weight equal to the integer value of some sort of user input. So let's say they put in like 185 or something, okay? Okay, well, if I option click on weight here, what is the type on weight?
Optional int.
It's an optional integer, okay? And that's what the compiler is inferring the type to be, okay? And why is that the case? Why is the type inferred to be an optional integer? I didn't say that I wanted this to be optional, but it is. And why is that?
Because of the quotation.
Because the quotations, right? This can literally be anything, right? So if I say ABC, what is the value of weight? If I were to print out weight, what would weight be?
ABC.
No, because what's the type on weight? Is ABC?
Oh,
an
it would be
integer?
It would give
nil.
you a fatal error.
So not a fatal error, it would just be nil.
Oh, yeah.
It would
right?
be nil.
And that's the point of optionals, right? So that we get away from that idea of fatal errors and allow for like, if the user inputs something that doesn't work, the value is nil, okay? So the value of the integer value of ABC is going to be nil, right? So if I print out weight here, okay, we see that the value is indeed nil. Whereas if I do 1, 2, 3, the value is optional 1, 2, 3. Okay, and we'll talk about that in a sec. But okay, so let's do a bigger example here. So again, a UI text field is going to be the standard way that people are going to type text into iOS, right? You've seen those all over the places when you're filling out forms, when you're putting in your email address, your password. You have text fields that allow the users to type in anything they want. And that keyboard, every character that's input from that keyboard is just appending to like a string, okay? It's not like generating numbers or anything. They're literally just strings. And so there's a chance that someone can put in like an invalid number or whatever. And so we want to be able to handle those cases where possible, okay? So let's say that that the user has a text field and they're trying to calculate a tip, okay? Well, let's say that the subtotal, or the string that they pass in is going to be 58.95. Okay, that's what they type in their keyboard as like the total bill that they have. Okay, well, I want to verify. I don't want to calculate a tip unless I know that my subtotal can actually be converted to a numeric value. Okay, so what we can do is we can do what's called optional binding through an if-let statement. Okay, so we use an if-let statement to unwrap an optional value, okay? So let's go ahead and say if let subtotal equals the double value of my subtotal string, then we can calculate our tip, okay? So we'll say let tip equal subtotal times 0.2. Let's say we're big tippers paying 20% tip. And then let's calculate the total. Let total equal subtotal plus our tip. Okay, and then we'll print out total and interpolate the total. Let's interpolate our, well, actually, let's do a new line character. Okay, and then we'll do our, let's interpolate a tab as well. Okay, and then we'll do our subtotal here. Subtotal. Okay, and interpolate the subtotal value. And let's put another new line in and another tab. And then say tip. Sorry, I realize this string is getting really messy. I'll explain it in a sec. Okay. So again, subtotal is going to return as a double value if the double value of my subtotal string can properly be converted into a double value. Okay, that's what this if let is it's saying if this has a value that is not equal to nil, then assign it to this constant called subtotal. Okay, so it's sort of this like combined conditional unwrapping where we're saying if we have a value here, then assign that value to subtotal. So then subtotal we know is not equal to nil, right? Otherwise, we wouldn't get into these braces here. Okay. So otherwise, we'll go ahead and we'll print out our subtotal string is not a valid amount. Okay, so we'll go ahead and run it here. Okay, and to explain this string, so what I'm doing is I'm just sort of piecing together my total, my subtotal, and my tip, and I'm separating them by new lines and tabs. Okay, so that's what the \n and the \t. Remember, the backslash is an escape character. So if that's followed by an n, it's new line, and if it's followed by a t, that's for a tab, right? So we can see that when we print this out, that subtotal and tip are both tabbed in and on separate lines, okay? But that's not really the important part. The important part is that subtotal here is going to be the unwrapped version of my subtotal string converted to a double, okay? So we see that the total is $70.74, or, well, let's see here. Oh, I think I did that wrong. Total. Oh, I see. Okay, yeah, so the total amount is going to be 70. The subtotal that they gave me is 58, and then my tip is 11, right? So it's sort of the breakdown of my tip calculator, okay? But the only reason that I was, oh, yeah, go ahead.
If we wanted to shorten those numbers, you know, like you see how there's like 13 or 14 or whatever decimal or like place after that, like if we wanted to shorten it down just to the 74 or the 90 or the 79.
You can use a float, right?
Yeah, use a float.
Yeah, or what you can do is you can we could do like total.rounded, and you can set specific rules. But if you just wanted to round these, that will, I believe, rounded does to the nearest integer. Let's see if I run this. Yeah, that rounds all of them. But yeah, a floating, like if we had this set to a float and took away the rounded here, If you want to get like really specific of like, I want to round to, you know, this specific, you know, 3 decimal places or whatnot, I believe if you use the rounded, you can set like a rule, or you can use like a number formatter to do that as well. Okay, so then that rounds them as well. Okay. So questions about the if let? Why we need to use them? Okay. All right. So, and again, with that, so subtotal, this subtotal here, this constant that we create for subtotal can only be used inside of the scope of these braces here. Okay. So I can't access subtotal like out here if I wanted to print out my subtotal, right? I still only have access to the subtotal string. Subtotal is only used inside of these braces. So it's just a local, it has like a local scope to these braces here.
So, but how can we do you use it in the function when we pass in like something optional there?
Say that one more time.
How can we use it in a function or method when we doing this unwrapping, the optional value unwrapping?
Yeah, so if you had a method, so if we had a func calculate tip, and we pass in a like a total string and pass in a string optional, or actually let's just do total of type float. Okay, and then I'll move all of this logic inside of my function. Command S, Command V. Okay, what we're going to do here instead is we're going to, well, again, I don't need to take the float value. I can just take the, sorry, I should make this optional. And I guess to go along more with what we were just doing, we'll say a total string and change this to total string. Okay, so right now the compiler is going to say, run this. Okay, so total string right here, this is going to return like the optional value. And so in order to specify that I need to unwrap subtotal, I'm going to make sure that total string can be optional. And then, come on, let's see. Oh, I see. Yeah, this is allowing for us to pass in a, like pass in a nil string, which you can't convert the float value of nil, but you can convert a float from an actual string. But yeah, that same logic you can put into a function so that you can use it throughout. And so if I wanted to call, you know, calculate tip for, you know, $200 or something, we can run it and we see that the total would be 240. Okay, or if I called calculate tip and we passed in ABC, we'd see, oh, sorry, we need to replace this with our total string. We see that ABC is not a valid amount. Okay, does that help visualize it in the context of a function? Okay, all right, so we're going to spend the last few minutes talking about force unwrap syntax, okay, and why it's not always safe, okay? So there is a way to force unwrap an optional value, but you only really want to use it if you are like 100% sure that the value is not going to be equal to nil. Because if you ever force unwrap, if you're trying to access a property and you force unwrap it and try to use it, and the value is nil, then it will crash your app. Okay, and so generally we always want to use this this idea of using an if-let statement to unwrap our optionals, so that we like safely use values if they exist. Otherwise, we don't do anything with them. Okay, but there is a way to make sure, like, I don't care, just use it. I want to force unwrap it. Okay, so let's say that I've got a property for years old. Okay, and we'll say it's an optional integer and its value is equal to nil. Okay, well, I'm going to go ahead and we're going to say let approximate days old equal 365 times years old. Okay, well, we're going to get an issue here. It says, hey, you're trying to multiply an integer by an optional integer. Okay, so what I need to do is, if I want to get rid of the optionality of years old, I can use an exclamation point to force unwrap it, saying, I don't care about the optionality here, just force unwrap it and use it. Okay, so now we can print out, wow, you are, we'll pass in our approximate days old, put days old here. Okay, so if I run this, we get a fatal error, right? Unexpectedly found nil while unwrapping the optional value, approximate days old. Okay, or sorry, years old, not approximate days old, years old. Okay, because I force unwrapped a property that was equal to nil, and then I tried using it. Okay, and so we got a fatal error. Okay, so you only want to force unwrap something if you like are for sure, like 100% that the value is not equal to nil, right? So in my case here, if I set this equal to 35, okay, well, I'd feel pretty good about setting this to an exclamation point, because I know that years old is equal to 35, right? I know that it's not equal to nil. Okay, so that's really the only time that you should ever use this bang operator, is what we call it, is if we are 100% sure that the value is not going to be equal to nil. Okay, but again, let's talk about how we can handle this, right? How we can be more defensive in the way that we write our code, so that we don't accidentally have like fatal errors in our program. Okay, so let's try this. Let's go ahead and we're going to check if years old is not equal to nil. Okay, then anything inside of this block, we're guaranteed that years old is not equal to nil. Okay, so I can say, well, let's just copy this. Let's copy these and paste it here. Okay, and here I'm fine to force unwrap it, right? Because years old I know is not equal to nil. Okay, so I'm fine that this code gets executed because I'm guaranteed that years old is not equal to nil, because I'm checking on that condition. Okay, or what we can do is put this in an if-let. So we'll say if-let years old equals years old. Then we can, again, let's just copy this, paste it. Okay, and here I don't need to force unwrap years old because it's already going to be unwrapped for me, right? This years old here is going to be the unwrapped form of years old. And otherwise we'll print out, you don't have an age. Okay, so again, in all of these cases, it's printing out how old I am. But those are two ways to safely handle your optional, rather than using the bang operator. Okay, is either checking that years old is not equal to nil, and then you can safely use the bang operator, or you can just simply use the if-let and run the code given the case that years old is not equal to nil. Okay, so those are two ways to kind of not have to use the bang operator in an unsafe way. Okay, other questions about handling optionality? Okay, sounds good. Well, we do have some extra time. I mean, I guess just a few minutes. But if Samira or one of the other TLs, if you guys wouldn't mind posting the homework, those of you who feel good about all of this stuff, you're welcome to hop off the call and get started on your homework or do whatever you want to do. But I'll stay until the end of our time, until 8:30, and even later if I need to answer any questions or resolve anything that you guys are curious about. So thanks for coming, and we will see all of you on Wednesday.
Thanks.
Thanks, Johnny.
Okay, we'll see ya.
Thank you.
Thank you.
Johnny.
Does I think it's nil coalescing. Does that fit into all this?
Yeah, we're going to talk a lot more about nil coalescing, I think, on Wednesday. So we'll get into that because, yeah, like pretty much our whole next lesson is like heavily focused on optionals. We touch on it here, but we'll talk a lot about optionals in our next lesson.
I noticed we haven't really gone over how to get user input yet. Is that because we're focusing more on app creation rather than like a different kind of language?
So it's the opposite. So right now we're just focused on Swift. When we get into our iOS fundamentals, that will actually like integrate building apps, because we don't have, like, until we actually build an Xcode project that has like view controllers where we have user input, we don't really have text fields like to get user input. So yeah, as soon as we sort of switch gears from Swift and the playgrounds and move more into Xcode projects, that's when we're going to be handling user input.
Hey Johnny, did you go over how to put like a pull request and tag their TL in this before lecture?
No, I have not done that.
Okay.
If you want to meet with your group separately to do that, that would be awesome.
Okay. Yeah, I'm most of mine know how to do it. I just wanted to make sure.
Cool. Yeah, I failed to go over that this time. Oh, I even failed to go over like actually committing and pushing our changes. I always forget about that. Let me go ahead and we'll add our changes and commit them. Finished fundamentals playground.
I submitted the homework, or I put up the homework in the channel for everybody.
Okay. All right, guys, any other questions? All right. Well, if any other questions come up, feel free to reach out to me or to your TLs. We're always happy to help. But yeah, if nothing comes up, then we'll just plan on seeing you all on Wednesday.
Thank you.
Yeah, have a good night, guys.
Good night.